Dear students, today we will be talking about velocity and acceleration in plane polar coordinate system. So our aim is to find the expressions for velocity and acceleration of a particle in a plane polar coordinate system, right? We know that position vector r is given by r cap, where r is the magnitude and r cap is the direction of this r, vector r, right? Now, velocity will obviously be given by dr by dt, time derivative of this r. So it will be dr by dt r cap plus r times dr cap by dt. So this is how much? This will be written as r dot r cap plus r times. Let us break this factor by means of chain rule. So we can write it as dr by d theta by dt. And why did we do that? Because in this velocity expression, we need to incorporate for both terms, the radial component as well as the angular component, because we know that plane polar coordinates are two, and they are r and theta. So it is our need to express this velocity in terms of r as well as theta. This is the reason that we have tried to break this factor by means of chain rule to incorporate for theta, right? So this is r dot r cap. This is r. You have done it previously, that dr cap by d theta is theta cap, and d theta by dt is obviously theta dot. Now we can choose to rearrange it. R dot r cap plus r theta dot theta cap. Therefore, this velocity in plane polar coordinate can be written as Vr plus V theta. That is, it has two components, a radial component given by this and an angular component given by this, V theta, right? Therefore, if you have to find the magnitude of this velocity, obviously it will be given by the square of the terms, this term and this term, that is Vr square plus V theta square, or more properly, we can choose to write it as, what is Vr? Magnitude only, r dot square. And what is V theta? Magnitude only, r theta dot. So it is r square theta dot square. Now, similarly, we can proceed for acceleration. So acceleration, obviously, it is dv by dt. So that is d by dt of, what is v? We have found that v is this much. So it is r dot r cap plus r theta dot theta cap. So let us differentiate it. Differentiation of r dot will be r double dot, then r cap, then r dot will remain as such. Differentiation of r cap. Similarly, we can choose to differentiate these three terms one by one. Differentiation of r is r dot, theta dot will remain as such, theta cap will remain as such, then r will remain as such. Differentiation of theta dot is theta double dot, then you have theta cap, and then another term is r theta dot d theta cap by dt, right? Again, we will try to break these factors, r and theta, because we have to try to bring this expression more properly in terms of r and theta, right? So this will be r double dot r cap plus r dot. For dr by dt, we can write dr cap by d theta by dt plus r dot theta cap plus r theta double dot theta cap plus, we can break this, r theta dot, this will be d theta by d theta cap by d theta into d theta by dt, right? Now this is how much? R double dot r cap plus, see, d theta by dt is theta dot, and dr by d theta, you have already done that, that is theta cap. So this and this factor is identical. I can write twice r dot theta cap, right? For this, it is r theta double dot theta cap plus r theta dot, what is d theta cap by d theta? You have done that in the previous video. That is minus times r cap, And what is d theta by dt? That is again theta dot. Now all we have to do is that we will separate the radial components and the angular components. So it will be r double dot. Here it will be minus times r theta dot square. Theta dot square. So enclosed. Then the next is the angular component, that is r theta double dot. It's better to write the higher derivatives first. R theta double dot plus 2r dot theta cap. So this is the radial component of acceleration and this is the angular component of acceleration. Obviously, therefore acceleration is ar, the radial component, plus the angular component. And similarly, as in case of velocity, we can write the magnitude of acceleration will be given by square root of ar square plus a theta square, where square of ar actually means square of this entire term and square of this means square of entire term. So this is the expression for velocity and acceleration of a particle which has been fitted in a plane polar coordinate system. Now next we move to what is the relationship between the velocity and acceleration components of plane polar coordinate system to that of Cartesian coordinate system. Let us try to see how can we connect them. Now let's write the basic equations again. So what do we intend to do? We want to find out what is the relation between velocity in plane polar coordinate system and Cartesian coordinate system. I'm writing in short. So similarly, what is the relation between acceleration of a particle in plane polar coordinate system and Cartesian coordinate system, right? So let us first choose the velocity. So again, I will write the basic equations, that is x is equal to r cos theta and y is equal to r sin theta. So let me differentiate them with respect to time. And why do I do that? Because I want to find the velocity. So x dot is r dot cos theta. So I've differentiated this, kept this. Now differentiation of cos theta will be minus sin theta. So it will be minus r sin theta, and then internal differentiation of the angle, that is theta dot. Similarly, y dot will be r dot, differentiation of sin theta is cos theta, plus it will remain as such, that is sin theta, right? Sin theta. So we have differentiated r dot, and sin theta will remain as such. In the next, it will be r, differentiation of sin theta is cos theta, theta dot, internal differentiation of the angle. Now all we need to do is that let us multiply this equation by cos theta and this by sin theta and add them up. So x dot cos theta is equal to r dot cos square theta minus r sin theta cos theta, theta dot. And now let us multiply this by sin theta. So y dot sin theta is equal to r dot sin square theta plus r times sin theta cos theta, theta dot. Now once we add this and this, these factors are same, they will cancel. This will be r dot and the sum of these two will be 1. So what are you left with? You are left with r dot is equal to x dot cos theta plus y dot sin theta, right? If you want to express this equation back in terms of this x and y, so you need to multiply by r, right? So it will be r cos theta, r sin theta, and of course you will have to divide by same r. So r dot is x dot r cos theta plus y dot r sin theta divided by r. So we are multiplying by r and dividing by r. Now what is r cos theta? It is x and then it is x dot. So it is x dot plus y dot divided by r. Can be again expressed in terms of x and y. We know previously, based on our previous knowledge, that x square plus y square is equal to r square, equation of circle. So r is written as under root of this. So for r we can substitute, it is x square plus y square under root. So this is the relation between the velocity of a particle in a plane polar coordinate system to that in Cartesian coordinate system. In Cartesian coordinate system, we express the velocity components as x dot, y dot, and in case of plane polar coordinate system, we represent the velocity components by r dot. But we also know that in case of a plane polar coordinate system, the velocity has two components. One is the radial component r dot and another is the angular component, right? Now for the angular component, that is theta dot, we will proceed as multiply this equation by sine theta and this by cos theta and then subtract them. So let's do that on the next page. So we multiply this equation by sine theta. So x dot sine theta is equal to r dot sine theta cos theta minus r sine square theta theta dot, and then multiply this equation by cos theta. So it is y dot cos theta is equal to r dot sine theta cos theta plus r cos square theta theta dot. Now let us subtract this from this, right? So it will be y dot cos theta minus x dot sine theta. Now once you subtract this from this, they are identical factors, they will cancel. Now once you subtract this from this minus becomes plus, and now the sine square and cos square becomes 1. You are left with r theta dot only, right? I hope that's clear. When we subtract this from this, they are identical factors, they will cancel. And when you subtract this from this minus becomes plus and they actually add up. Once they add, r and theta dot are common and this sums up to 1. So I've written the final expression. Now you are interested in r theta dot and you have found that actually. So theta dot is how much? Theta dot is y dot cos theta minus x dot sine theta divided by r. Again we shall use the same principle that we intend to bring this theta dot purely in terms of x and y. Therefore I will multiply and divide by r. For r cos theta I can write x and for r sine theta I can write y, right? So theta dot is y dot r cos theta minus x dot r sine theta. Since we also have to divide by r, it will be r square. So it is y dot x, because x is r cos theta, minus x dot y divided by, for r square you can write it is x square plus y square, simply. But if you recall that the expression for velocity in case of plane polar coordinate is v is equal to vr plus v theta. Vr is r dot, but v theta is r theta dot and not just simply theta dot. So we also need to multiply by r again, right? So because v theta is actually r theta dot, right? So we will be multiplying this expression again by r, right? So it will be r times this expression, that is y dot x minus x dot y divided by x square plus y square. Now what is r? It is x square plus y square under root. So one of the power, half power, will get this cancelled with this and you are left with only half power, right? R square is x square plus y square. So simple r is under root of x square plus y square. So one of that will cancel with this and you are left with root power only. So you are left with, more properly, xy dot minus yx dot divided by x square plus y square under root. So this is the expression for the angular component of velocity, right? Now as an assignment I can ask you to do the similar exercise for the relation between the acceleration of a particle in a plane polar coordinate system to that in the Cartesian coordinate system. You have to repeat the same exercise basically. See, you have to begin with the same equations. This equation. But since at this moment you are interested in finding the acceleration of the particle, you will also have to take another derivative. That is, in the next equation, you will write x double dot and you will find y double dot. You will simply get two expressions. Then in the same manner, what we have done here is that you will multiply this equation by cos theta and this by sin theta and add them up. In the next step, you will multiply this by cos theta and this by sin theta and subtract them up. So you will get the relation between the acceleration and of a particle in the plane polar coordinate system and that in the Cartesian coordinate system. So obviously we are going to obtain a similar result. That is this. See, for the radial component of velocity, you obtain this kind of an expression. Now for the radial component of this acceleration, radial component, right? Radial component, you will obtain a similar expression, but this time it will be x double dot plus y double dot divided by x square plus y square raised power 1 by 2. It will be similar. The only thing that you have changed in the beginning is that you have taken a double derivative of x and y. So you have taken x double dot and you have taken y double dot. And then you have followed the same scheme of derivation, same scheme. Therefore, in the end, you are only going to get x double dot plus y double dot divided by this much. And this will be the radial component of acceleration connected to the components of acceleration in the Cartesian coordinate system. Similarly, how will the equation get modified over here? The angular component of acceleration in the plane polar coordinate will be given by x y double dot minus y x double dot divided by the same thing, that is x square plus y square raised power 1 by 2. Again, you will follow the same scheme of derivation. I am repeating it. There is no need of doing it again. You can do it as an assignment at your places. Again, you will start from here, that is x is this much and y is this much. You will take the derivative x dot and y dot. But in case of acceleration, you have to move one step forward. That is, you have to take x double dot as well and y double dot as well. And then do the same thing as we did here. That is, multiply this equation by cos theta, this by sin theta and add them up. In the next step, you will multiply this by sin and this by cos and subtract them. And you will get the relation that connects the acceleration in plane polar coordinate system to that in the Cartesian coordinate system. And that finishes this topic.